Let's see the third question now. Now, if you pay attention to the question, it's slightly different than what we have done in question number 1 and question number 2. What difference do we see is, here there is a binomial and here there is a trinomial. Product of binomial and a trinomial equal to 128 is what is given to us. Again, let me tell you, this isn't degree 2 sum, this is degree 4 sum. Now here, if you have any question that, sir, how come degree 4 sum? So if I go for expansion or multiplication of the first binomial with the second trinomial, just tell me, what is x square into x square? X square into x square is x raised to 4. So what has the degree turned out to be? Degree is 4. But yes, solving this sum is slightly bit different. Again, method of substitution is there in this one, but a bit variation in this. What is that? Children, here it is given to us is x square plus x. Here also we have x square plus x. Ignore this. Do we have a binomial x square plus x in each of the terms? Common? Indeed. We have in the first term x square plus x. In the second term also x square plus x minus 2. We do have x square plus x. So this time our substitution will be, let x square plus x is equals to m. Our substitution will be, let x square plus x is equals to m. So wherever there is x square plus x, we'll write down it as m. So the first bracket will turn out to be as m into x square plus x will be written out as m minus 2 is equals to 120. Open down. M into m, m square. M into minus 2, minus 2m. Bring this over here, minus 120 equals to 0. Now children, do we have a quadratic equation? Indeed. Very simple are the factors. So when I split it out, now I'll not write down sum and product. By this time you should be. Any answers? Minus 2 should be the sum. Product is minus 120, I'm sorry. So what are the two numbers? Minus 12 plus 10, m square minus 12m plus 10m minus 120 equals to 0. Minus 12 plus 10 minus 2, minus 12 into plus 10 minus 120. Methodology is the same. We try to remove common m minus 12 plus 10 m minus 12 equals to 0. Once again check whether we are right or wrong. M into m square, m into minus 12, minus 12m, plus 10 into m, plus 10m, plus 10 into minus 12, minus 120. M plus 10, m minus 12 is equals to 0. M plus 10 equals to 0, or m minus 12 equals to 0. M is equals to minus 10 or m is equals to 12. Now, I think there are very handful of students who might be thinking that, do we need to discard any negative value? Is there any condition? No children, nothing to discard. We are yet to go for resubstitution because we have got answer in terms of m. Our actual variable was x. So as we did in the previous two sums, we go for resubstituting the value of m. So what is m? This time it is x square plus x. X square plus x is equals to minus 10, or x square plus x is equals to 12. Children, we bring this over here, x square plus x minus 10 when it comes over here becomes plus 10 equals to 0, or x square plus x, when this comes over here, minus 12 equals to 0. So now, unlike in the previous two sums where we had m square as something, z square as something, or a square as something, and we got final answer, here we have quadratic equation. The first one is also a quadratic equation. The second one is also a quadratic equation. So now we have two simple quadratic equation which we are supposed to solve it, right? Now one thing is what I'll tell you, that whenever a particular quadratic equation is not getting solved via method of factorization, that means if we are not in a position to find out factors very easily, immediately we are supposed to switch over to formula method. Children, keep this in mind. I reiterate, once again I say so. In a particular quadratic equation, if we are unable to find out the factors, if the factors doesn't exist in integer terms, then immediately we are supposed to find out the factors via formula method. I'll show you what exactly I'm trying to say. X square plus x plus 10 is equals to 0. So out of the two, we have to take both, mind you, but we'll take one by one. So let us take this first. So first we say, let's take first this one, x square plus x plus 10 equals to 0. So now we'll first solve this one and then we'll take this one also and try to solve it. Children, what is the sum? Sum is plus 1. So if you want, you can write down. Sum is plus 1. What is the product? 10 into 1. Product is plus 10. Product is plus 10. Now we need two numbers whose sum is plus 1 and product is plus 10. I want, children, you give a thought for a minute or so. So you should try. Are there any numbers? Two numbers, mind you, whose sum will be plus 1, product is plus 10. Any idea? Any guesses? Very soon is what? You will tell me, sir, there are no such numbers whose product is 10, simultaneously the sum is 1. You might say, sir, 5 2s are 10, 2 5s are 10, but is there any relation between them which will give me sum as 1? No. So we cannot look only at the product part, we have to look sum as well as product. So when we don't have direct factors, we have to by default switch over to formula method. And those who have really seen my videos earlier, formula method, before proceeding with the formula method, what we find out? Anybody, any idea, any guesses? What we find out before applying formula? We always find out, yes, we always find out b square minus 4ac. If you have forgotten, refresh, as what we have said. This videos and this particular company is for you people, saying refresh concepts. So refresh yourself, refresh it and say that what was the thing we have found out? B square minus 4ac. So we need to comparing with ax square plus bx plus c equals to 0. My a turns out to be 1, my b turns out to be 1 and my c turns out to be 10. My a turns out to be 1, b turns out to be 1 and c turns out to be 10. So we first find out what is b square minus b square minus 4ac. B square minus 4ac, which is equals to, what is b? B is 1 square minus 4. What is the value of a and c? A is 1, c is 10. A is 1, c is 10. 1 square is 1 minus 4 ones are 4 into 10 minus 40. What is the answer? Minus 39. Minus 39, children. So what is the value of b square minus 4ac? B square minus 4ac is minus 39. So is there any roots? Roots are certainly there, but the roots are imaginary, not real. As we have studied earlier, if b square minus 4ac is less than or equal to 0, roots are imaginary, not real, and we do not consider it. So we'll write down the same thing over here. Since b square minus 4ac is less than 0, therefore the roots are not real. The roots are not real, and therefore, and hence we do not consider it. So those who feel that answer doesn't exist, answer exists, but the roots are imaginary, mind you. There exists an answer, but the roots are imaginary, and we do not take imaginary roots. Now we are left with the other quadratic equation. So we say, now we take the other equation, x square plus x minus 12. X square plus x minus 12 equals to 0. Do you think so that we have possible factors for the same? Indeed. What is the sum? Sum is plus 1. What is the product? Product is minus 12. What is the answer? Plus 4 minus 3. X square plus 4x minus 3x minus 12 equals to 0. Common, x plus 4 minus 3 x plus 4 equals to 0. X minus 3 x plus 4 equals to 0. X minus 3 is 0, or x plus 4 equals to 0. X equals to 3 or x equals to minus 4. Now those who feel that, sir, in the starting of the video said that we have 4 roots, or rather degree is 4, so we should have 4 roots. As I stated earlier, x square into x square is x to the power 4. We should have 4 roots, as I have stated in my earlier videos also. Children, we are having 2 real roots and 2 imaginary non-real roots, right? So that's the answer. We have only 2 over here, so we write down in our solution set. We have 2 roots over here. One is 3, the other is minus 4. I hope you have understood how we tackle these kind of sums, how we go about with these kind of sums where the roots are imaginary.